Okay, here's question 8 from the Core 1 mock. You get given dy by dx in this question, and then first of all you get asked to find d squared y by dx squared. So that's the second derivative, so you take the derivative which we're given and differentiate again. Okay, there you go, so the 54 disappears, the 27x just becomes 27, and then the 2 would come in front to give me minus 12 and I'd reduce the power to a single x. Okay, the next part says, which just note in your mind when you're doing these questions is a part 2, so we're going to have to use something from part 1. It says the curve passes through the point P. Verify the curve has a minimum at P. Now to verify that it has a minimum at P, you can't just sub the values into d squared y by dx squared. That doesn't show that it's a stationary point. You could sub any values into the second derivative and the majority of them will give you either a positive or a negative solution. So you could claim that almost any point was a minimum or maximum if you just did that. What you have to do first is to verify that it's stationary. So a stationary point occurs when dy by dx when the gradient is 0. So that is the first task. So again, to show the examiner and know what I'm doing, I'm saying when x is minus 3 over 2. So I've just changed the mixed number there to an improper fraction because it's much easier to deal with. When x equals that, and I've subbed it into dy by dx, you work through it, you know what you expect to get. It's a verified question. It's not asking you to say if it is a minimum, it's telling you it is, show me, prove to me that it is. So the proof that it's stationary to begin with is that when you sub x is minus 3 over 2 into dy by dx, we get a gradient of 0, and we need the statement, therefore, a stationary point at P. So now we've shown that it's a stationary point, we need to show that it's a minimum. So the minimum or maximum, when we're asked that, we use the second derivative. And that's why this is part 2 of part A. Okay, so I've said when x is minus 3 over 2 again, and I've subbed it into d squared y by dx, and we get that it's 45, so we're always going to say greater than 0 or less than 0, and then make the statement. So in this case, 45 is greater than 0, therefore it is a minimum. This question is 4 marks. If it was just one of those processes, it wouldn't be 4 marks, it would just be 2. So another hint that it involves both these steps is the amount of marks. Okay, part B says show that at the point on the curve where y is decreasing, and then it gives the inequality. This word here is the clue. When is y? Okay, y is my curve. When is it decreasing? What does decreasing mean? Well, decreasing means it's going down, and that's when the gradient is negative. So we're saying, right, when is dy by dx negative? And negative is when it's less than 0. Okay, so as soon as you realise that, just go with it. Because as soon as you do this, as soon as you say, right, look, it's decreasing when the gradient's less than 0, so I've got an expression for the gradient here. So I'm going to set that, and I'm going to say, right, my gradient's less than 0. And hopefully then you can see, hang on, I'm trying to get to this because it's a show that question. And look, that's not that dissimilar. What's happened? Right, okay, so if I divide each term by 3, I'm going to get exactly the same terms in here. They're just going to have different signs. What else is different is my inequality sign's the wrong way around. But that's because if you want to change all the signs of these, you simply take them all over to the other side, changing the sign, but also changing the inequality symbol around. Then you get what you're after. It's a good example of a question where you just have to do it and you'll see that it works out. You're not always going to be able to spot the exact route and the exact method that's going to get you from your starting point to your finish point. Sometimes you just got to do something, have a go. Can you think, does it look like it could turn into that? And if so, just go with it and hopefully it will turn out the way you want it. Okay, the last part wants us to solve that inequality then, so it's the inequality we've just come to. Alright, whenever you're solving an inequality, the steps are you make it an equation, you solve the equation, you find the critical values, i.e. the solutions to the equation, you use those solutions to the equation to sketch your graph, and then it's using your graph and looking back at the inequality sign, and it's those two things together that enable you to solve the inequality. We don't try and solve an inequality algebraically. Okay, so like I've just said there, we're going to solve the equation first. So I've set my equation equal to 0. I factorised it and I found my two critical values. And it's these values we're gonna that are going to be part of my solution, but we need to use the graph to see what the inequality sign that goes with each corresponding value. So you can see the graph that I've sketched there, and I've highlighted in yellow above the axis, and that's because if you go back to the original equation, we're finding out for what values of x is my curve greater than 0, so it's the bits above the y-axis. And that would be for any value of x that's to this side of 6, because anything to this side would give you values above the x-axis. So that would be any value of x greater than 6, or any value of x less than minus 3/2 would give you a value above the y-axis.